Welcome to Podkey Slopcast, where local AI economics and resilience get a proper stress test. A lot of the AI boom still assumes cloud access stays cheap, available, and politically uncomplicated. The case for local models starts to matter when you ask what happens if any one of those assumptions breaks. One of the more underappreciated risks in API-first AI is that your bill can jump even when your behavior does not. The example here is tokenizer drift. A model update like Opus 4.7's tokenizer reportedly pushed some companies' costs up by as much as 35% without any prompt changes. That matters because token pricing looks precise, but the underlying unit is not as stable as many buyers assume. If the tokenizer changes how text is chopped up, the same work can become more expensive overnight. Then agentic workflows amplify that problem. If an agent takes 10 steps instead of 2, token usage does not rise a little. It can compound across planning, tool calls, retries, and self-checking. So the real issue is not just headline price per million tokens, it's volatility and multiplication. A small pricing or tokenizer change lands much harder when your architecture already encourages lots of model turns. The Fable 5 shutdown is a useful reminder that single vendor dependence is operational risk, not just procurement inconvenience. If a provider disappears, gets blocked, changes terms, or has a prolonged outage, your AI layer can fail all at once. That is especially uncomfortable if core workflows or customer-facing features depend on one remote model. There is also a geopolitical angle. Export controls, regional restrictions, or cross-border data rules can turn a normal cloud dependency into a sudden access problem. Running models locally does not eliminate risk, but it does remove one very specific failure mode, the entire service vanishing because someone else's business, policy, or infrastructure changed. The broader backdrop is compute shortage. Leaders like TSMC and NVIDIA are signaling that demand may outrun supply through the end of the decade. That does not automatically mean every company should rush into server rooms, but it does change the economics of idle internal hardware. If you already own GPUs that sit underused, those machines are effectively dormant capacity in a market that keeps saying capacity is scarce. The strongest version of the local-first argument is not ideological. It is that shifting some predictable workloads from cloud to on-prem can reduce exposure to both market shortages and cloud bottlenecks. The weaker version is treating local hardware as free. It isn't. Idle hardware still needs power, maintenance, replacement planning, and people who know how to operate it. When people talk about GPUs for AI, they often talk about raw speed. In practice, VRAM is usually the first hard limit. A model needs to fit in GPU memory for acceptable performance. If it spills into CPU memory, speed can collapse. That is why memory shortages distort the market. A decent gaming GPU around $2,000 sounds expensive because it is, but the price pressure is coming from a capability people suddenly care about a lot more. The same logic helps explain long waits for Apple Silicon devices. Unified memory makes those machines interesting for local inference, so memory-rich configurations become strategic rather than merely premium. This is also why the frontier model conversation can be misleading for normal users. Many tasks are constrained less by intelligence ceiling than by what can be run fast enough on available memory. There is a tendency to frame local AI as an all-or-nothing replacement for the cloud. The source material points to a more tiered reality. Tiny models in the 1 to 4 billion range can already handle lightweight chat, summarization, and basic instruction following on phones or modest devices. The 7 to 14 billion class is probably the practical center for a lot of desktop knowledge work. That is where local AI starts to look useful, rather than merely impressive. Large frontier models still need multiple GPUs or enterprise servers, but they may be overkill for many internal tasks. And parameter count by itself is a weak shortcut. A specialized 3B model like Viv Thinker can reportedly punch far above its size on narrow coding benchmarks, which tells you capability depends on training and specialization, not just scale. Quantization is one reason local deployment is more feasible than many people assume. By compressing weights, something like Q4 can shrink memory demands enough to fit a 27B model onto consumer hardware in some setups. But compression is a trade-off, not magic. Higher precision formats like Q6 or Q8 preserve more quality and usually cost more VRAM, so the right choice depends on whether your bottleneck is hardware or model fidelity. Model selection gets more complicated because Hugging Face now hosts more than 500,000 models. Abundance is helpful, but it also creates a discovery problem. The smarter filter is not just benchmark ranking. Check tool calling, context length, image support, and whether the license is actually usable for commercial work. Apache 2 and MIT are cleaner bets. And read the model card and community comments. A model optimized for pleasant chat can still fail badly in agent workflows that require structured outputs, tool use, or reliability over many turns. The tiered approach here is sensible. Start with routing layers like OpenRouter when flexibility matters most. Move toward local or more controlled deployments when the driver is sensitive data, continuity, or cost predictability. Reserve fully offline setups for cases where resilience is non-negotiable. That sequencing matters because the jump from API use to self-hosting is not just technical, it is operational. Tools like Ollama and LM Studio reduce that jump. Ollama gives you a standard API and hardware-aware local serving, while LM Studio makes testing and comparison easier through a GUI. Those tools lower friction, but they do not remove the need for internal judgment. Ease of setup is not the same thing as production readiness. On agent frameworks, the split between OpenClaw and Hermes reflects a real design choice. Do you want explicit control over every skill, or do you want more autonomy and self-evaluation? Neither is universally better. Tight control helps when reliability and auditability matter. More autonomous frameworks may move faster, but they also increase the burden of evaluation. Security has a similar trade-off. A disconnected on-prem network can absolutely protect data better than cloud APIs, but only if the perimeter is hardened and maintained. If the local system remains internet-connected and poorly managed, calling it secure is mostly branding. In that case, you may just be swapping one attack surface for another. The enterprise ROI numbers are the final corrective here. If companies spend an average of $11.5 million on AI annually and only 12% of tools create measurable value, the bottleneck is not just model access. It is workflow selection, user behavior, and whether teams aim AI at revenue or cost outcomes instead of low-stakes conveniences like endless meeting summaries. So the strongest takeaway is not that local AI wins or cloud wins. It is that resilience, cost, and ROI all improve when organizations match deployment tier, model size, and operational burden to the actual job. That is the part of the AI stack worth paying attention to before the next pricing change or outage does it for you. Thanks for listening to Podkey Slopcast. This episode was generated by Podkey. Create your own at podkey.fm.